Thank you so much. Thank you everyone for joining us. And today I'm going to discuss about how the role of data engineering powers up analytics at scale at Netflix. So the concept is building bridges because we know there is a lot of data around us, and how do we make connections and use data engineering tools to share insights. So, a little bit about me. I've been at Netflix for around 4.5 years now, and I am working in the studio and creative production data engineering team, which actually deals with a lot of movies and how movies are produced, right from the script to how it is played on the service. So, I've been working on different teams at Netflix, and then prior to that, my main core skill is in data warehousing and data analytics. Yeah, and on a personal note, I do love, traveling, and I like reading books. Yeah, thank you for joining me and hearing and listening to this talk. So to start with, at Netflix, we have a pitch to play life cycle where it starts when a movie script is shared, and then it goes through a lot of phases, starting with deal negotiation, the um, what talent or what actor and actresses is going to join the movie, where it is going to be shooted, what VFX is needed to have in the movie. So everything, um, there are a lot of complexities that happens before a movie is launched on our service. And here we can see, let's concentrate on these three domains, which is pre-production, production, and post-production. So in pre-production, what happens, as I mentioned, you constantly refine the script and make sure the script is almost final, so that if there are any minor corrections to be made during the shooting, that can be made, but the script has a green signal to it. And then you have the production, where every day when so many types of cameras and media files are ingested, so there are various reports that are generated on every day on every location. So those are kind of the data points that we can retrieve while a movie is being produced. And also in post production, if you can see, like from the script, we can also know what type of characters will be there in the movie. And so we engage with a lot of VFX artists and different partners to give those animations and give those effects to the movie. So those things, the sound mixing and everything happens during the post production. So these are all the different phases it goes through, and so all of this data we store in Iceberg. So Iceberg is a table format, very performant table format, and it's used in the data warehouse world. And all of there are thousands of tables in the content and studio domain. Content, I mean, by the metadata that you see on the when the movie is playing. Say, for example, you see the synopsis of a title, you see the movie name, you see the credits on a title. And studio means what happens, like behind the hoods, before the movie goes into production. So I'll discuss about some of the data ingestion patterns, so that it gives you a foundational idea um, of how data modeling really plays a critical role before you hand it over to different machine learning scientists and data scientists to use that data. So how do we ingest data from all of these applications? This is one method, and this is a high-level data architecture. You can say there are numerous applications which have intake forms, or some user input feeds, which are which which land the data into their own backend systems. And we have an abstraction layer, which is the GraphQL, and it's actually a very nice way to aggregate the information and make sure um, there are so many microservices underneath that. So how do we connect different microservices and get to know, the relationships between one entity and another entity? Let's say, for example, you want to map a production to a location, a production to a actor, a production to a production schedule. So all of these are different entities and they have different attributes. But GraphQL is a very good platform to have all this connectivity established. So once everything, the schema and everything is created in the graph, we leverage data mesh as the data ingestion platform. It's a very self-serve tool. You can read more about it in this blog, in the Netflix tech blog on Medium. And so this enables the movement of data. So as I mentioned, all of the inserts, updates, deletes, they are stored on the backend systems. It generates the change data capture events, and then we enrich the data using the graph, and then we push the data into Iceberg. So that's the story about how to ingest the data. And then once the data is ingested, there are multiple query engines you can use, like Spark, Trino, to do further transformations on it, and then expose the data in the reporting layer using different applications. So this is one way of ingesting the data and making it available for reporting. But you can really imagine that some of the data sets can really land in a duplicate fashion. So there are so many teams at Netflix and so many different reporting use cases. There could be the same movie data landed in several different ways in the data warehouse. So how as a, for example, an end user in the data warehouse, how do I understand that which one is the correct one? So that's so important, and which one is having consistency and accuracy with the source systems. So how do we try to move away from isolated siloed data sets to something which is really core data model, so that it is very high leverage and has huge adaptability across the downstream teams? So there comes the concept of conformed dimensions. So as I mentioned, there are so many subject areas, right? Pre-production, production, post-production, and each of these subject areas has their own functions. So for example, in the pre-production stage, you have a lot of like resource hiring, location scouting. In production stage, you have a lot of media ingestion. In the post-production stage, you have editing, whether the movie is actually ready for the final delivery. So, and in all these stages, there's a backbone or the core thing that we see, which is the title. So how can we make sure that the IDs or the attributes that are for a title, and if someone wants to see data across different subject areas, um, and you might have heard about the concept of semantic layer. So that's where I'm coming to. So confirmed dimensions are very important integration into the semantic layer, where you have these dimensions which are very core to the so it is core to across the subject areas, and it simplifies the data integration. It actually also takes care about the query performance. So as I mentioned, we use GraphQL, and once you retrieve the data from Graph, it is not in um, a proper queryable format, right? We need to unnest it, we need to change data types, we need to do some modifications so that it is easy to query for other researchers. Um, so that is the main purpose of creating this data model, having like good auditing capabilities and having a good standards like best practices, and making sure that there are no duplicate copies of this data. And yeah, so here, this is a small kind of picture where the researchers, the scientists, and the analysts, they always look for like timely, accurate data, and they are seeing like data in the applications, and they are seeing data in the data warehouse. And when they don't match, then of course there will be so many questions. So we need to be very sure of how we integrate the data and make it like the concept of certification, like how would you build trust on the table that has landed on the in the data warehouse, so that everyone when someone is creating a report in one word in one subject area, and someone is creating another report in another subject area, they really tie to each other. The ID spaces are common. Uh, the values are okay. The attributes linked are okay. The roll ups work. The drill downs work properly. So there are a lot of things that are reliant on dimensions. So I'll actually dive deep into one of the use cases in Netflix. It's called screenplays, and screenplays play a really vital role, as I mentioned before. From a screenplay, which is the script, you can actually, gauge the budget of a title. You can see what's the size, what's the number of scenes, what are the number of characters. You also can understand production schedules, like how much time it will take to shoot the movie, which location is suitable to shoot the movie. Then we come to subtitling and dubbing, where you can look at the dialogues and see whether you need subtitling or dubbing. You have like different creative insights, and that reveals itself when you read a script. Ratings, complexity, so many things we can gather from the script, right? But um, it's not easy to scrape the data from a script. So how do we do it? This is a sample script, like it's Hollywood script. It's well formatted. It has its own standards, but of course, like globally, the scripts can be written in different formats. So I'm going to discuss only about Hollywood format here, where you can see you can identify a character, dialogue, action, page number, scene, character description easily. And how you can do that is through indentation and just understanding how the script is structured. So our ML engineers, they want to work on this particular script and identify and understand it. So they want to create a script understanding model. So using the abstractions or the data ingestion patterns I described earlier, we bring the data into the data warehouse in Iceberg, and from there, the ML engineers can actually create, on top of that, some models to make sure, like, to identify those things, like how many characters, how many props, and things like that. And that information, those embeddings, you can say, how you can leverage those in large language models is something which we can talk about, like what are the use cases there in the later slides. But what's the output of script understanding model? They are tags or embeddings. Tags means, say for example, you read a script, you can do an analysis of whether it's a rom-com or it's a mystery or it's both, right? So how you can tag a script and make and understand the genre of a script. So those kind of things happen, and those are really good insights to feed into a large language model for further predictions. So all of this data, we chose Iceberg because it's low cost, and it's in the data warehouse. We can actually, it's not, we don't need to put it in memory. It's used for historical analysis, so it's best to actually store in Iceberg and make it useful for multiple applications. So this is one of the data models we built, where you have the script, it has an ID and the embedding. But what happens is that this embedding is pretty large. And if you're using Trino to query the table, it really takes a very long time. It goes out of memory. So in that case, data modeling paradigms play a very critical role. How will you make sure, once you land the data, once you have the embeddings, how can other researchers query the data efficiently? Um, so that's where partitioning strategy comes, and you can actually have an abstract batch ID there to parallelize the different files, so that, like, each embedding is so long, right? You can split it into different partitions, so that when the query works on this particular table, it is more efficient. But this particular strategy needs to be there for every table where there is embedding. So that's where some standardization, some best practices come into play, and the role of confirmed dimension. So once this table is stamped as a certified table, then the practices that have been inherited included here can be leveraged in other places as well. We learn from such patterns, query patterns. So here, so I'm talking about, so let's say, for example, you have all the tagging and the embeddings created, where actually those data sets are used. It's used in a lot of places when a movie is being produced. It's like during the pitch, if let's say there are different similar shows, so looking at the script embeddings, you can actually predict which pitches are really similar to this one. In pre-production, of course, like if you have a new script coming up, you can actually predict if it has a similar budget to an historical title, or what would be the schedule estimations during the production phase. If let's say you have a scene which is very relevant to a particular cast, and you know that this has been successful before, and you can actually take the scripts, understand what characters need to be there, and figure out like what casting decisions need to be made. In the post production phase also, as I mentioned before, it's very important because visual effects is very costly, and if you can understand how much it will cost beforehand, it's worth it. It will actually handle a lot of overages at the end of a production, because we want to know where we are spending more, and if it is really needed for that movie. If there is really need for that movie, of course, then we go for that. So yeah, so that's all I had to present. But the core idea is to really focus on long-term data modeling strategies rather than just use a lot of tools in our hands and land the data as it is there in the source. We should look at the end user goals, how the data can be leveraged for multiple use cases, and build the data model efficiently.